Hello and welcome. So let's start with new paper, that is electronics and communication. So what we are going to do is questions of linear algebra. So if you are already following this channel, then we have already covered linear algebra from statistics paper and also from mathematics paper. So last 5 year question from these paper we have covered so far. And what we are doing, that we are solving only linear algebra question according to the syllabus of data science and AI, right? So today we will start with EC paper, that is electronics and communication, and we will look at these linear algebra questions. So this is 2023 paper. Okay, so let's jump directly onto the question, and we will see that how many questions that we have here in electronics and communication. So the first question is question number 11. We have 19. Okay, so this question number 11, we have given this v1 and v2, two vectors, right? The value of coefficient alpha in the expression which minimizes the length of vector e. So overall point is that we have given this two vector and we have given this expression. So we have to minimize the value of e. So for what value of alpha uh, we will have the minimum e, that we can call it the error also, right? So if you look at this expression from here, what we can say, that the e will be v1 minus alpha times v2, right? And if e will be minimum when uh, when this vector will be close to v1, right? So if it is close to v1, let's assume that it is v1, then e will be 0. So if you see that this problem has been derived from the concept of projection, right? If you have given this matrix v1, this vector v1, and if you look at this expression, then this v1 is the sum of this some vector alpha v2 and this e, right? So if you according to the law of addition of matrix, if you calculate from here v1, it will be alpha v2 plus e, right? So if we want to have this error minimum, then you see that this alpha v2 is nothing but the projection of v1, right? Projection of v1, right? So this alpha we will have to find. So this alpha will be v1, and it has been projected, so v1 transpose, it has been projected into v2, so v2 divided by so it will be uh, v2 transpose v2, right? So if you calculate this, what we are going to get, so v1 transpose v2, so v1 is here. If you take the transpose and calculate the inner product, what we will get is 2 plus 2 plus 0, right? And if we calculate this v2 transpose v2, then here we will have 4 plus 1 plus 9, so 4 divided by 14, that is 2 divided by 7. So the correct answer for this option, for this question, is option C, that is 2 divided by 7, right? So basically this question is from the projection, and that is all. If you are getting this, there are other methods to also solve, but this is the shortest way to solve this question. Now we can look at another question, that is question number 15, I think. Yes. So question number 15, let's see what it is asking. So let sets of eigenvalue and eigenvector of matrix B. So we have given this matrix B and we have given the eigenvalue and eigenvector of matrix B. So eigenvalue of matrix B, what we have given, that this set. So if you write it in simple term, then it is the set of lambda 1 till lambda n, right? So you can put lambda k between. So this is the set of eigenvalue. Similarly, we have given the set of eigenvector of matrix B. So let's call this set of eigenvector. Let's put all those eigenvector in a matrix. So we have given this set, right? So maybe this, let's put the v1 at this column and v2 at this column. So all these are eigenvector. So I am forming a matrix and calling that matrix as S, and we have this till vn. Look at this set, right? So this is what we have given in the question respectively. And so for this lambda 1, for this eigenvalue, we have given this eigenvector and so on. For any, now I'm reading next paragraph. So for any invertible matrix P, the sets of eigenvalue and eigenvector of matrix A. So we have also given this matrix P in the question. Now we have been asked that the set of eigenvalue and eigenvector of matrix A. So what will be the set of eigenvalue of A and the set of eigenvector of A, right? And where we have given that B is equals to, so we have the relation of B and this P and this A also. So in the question we have given this B is equal to P inverse A P. So regarding P, what we have given, that it is a invertible matrix, right? So the main goal is to find the set of eigenvalue and eigenvector from all this info, right? So this info we have given in question. So basically this question is from, I can say that it is from the diagonal eligibility of a matrix. So if you know how to diagonalize a matrix, then you will have the answer for this question. So let's make use of this given info, and let's try to find the eigenvalue and eigenvector of this matrix A, right? So we have given this B, right? So B is equal to P inverse A P, right? So let's isolate this P, right? And we have also given that this P is a invertible matrix. So let me isolate this A so that we have some info about A, right? So what we can do, we can multiply both side P, right? So here we can multiply P, here we will have P, so here we will have PB is equal to, so it will be identity, and identity times A, that will be same, so A P, right? Now let's do one more thing to isolate this A. So what we can do, we can multiply this side P inverse, also this side P inverse. So now we will have A is equal to, so this will be identity, and identity times A will be A, so A is equal to PB P inverse, right? Now we have given, now let's make use of this info, right? So what we are going to do, we are going to write the diagonal form of this matrix B. I mean to say, what I am going to do is write this matrix as, or diagonalize uh, this matrix B. So how we can, so so the main point is that what I am saying, that we can write this, or we can decompose this matrix in diagonal form, and here it will be matrix S. So what is this matrix S? So this is the matrix S. So S and lambda. So what is this lambda? So let's form a matrix lambda, that will be the lambda 1 here. So it is diagonal matrix. So this is diagonal matrix, and by putting all those lambda into diagonal, and so if you know the diagonal form, then I will not have to describe all these things. So we can write this B as a diagonal form. So S lambda S inverse, right? Let's substitute this here. So we will have A is equal to P, right? And here we can write B as in this form, like S lambda S inverse. Now we have this P, right? You see, what we can do, we can write this as a P S with one as a one matrix, and lambda, and sorry, here it is inverse, right? So here we will have PS inverse, right? So if you expand this inverse, it will we can open with the opposite direction, right? So it is same. So you see that now how we have written this A is now in diagonal form. So what we have done is we have decomposed the matrix A in diagonal form, right? So, and what we can call about this matrix, and what we can call about this matrix, so it is a matrix with eigenvalue, eigenvector, right? So it is P times, so S we have this V1, right? V1. So same as we will have the P times Vn, and again this lambda is same, right? Same as the this diagonal matrix is same as the B, right? So there will be no change on the eigenvalue, right? So we got the answer, right? So the eigenvector of A will be P times of this B1, P times of eigenvector of B, right? So, and eigenvalue will be as it is the eigenvalue of B. So if you look at this option, then option C is correct. You see that that this eigenvalue is as it is, that is lambda k. So as it is, and set of eigenvector will be get multiplied by P with the eigenvector of B, right? So option C is correct. Okay, now let's move to next question, that is question number 38. 29, 30, 32. Okay, so in 38 what we have given, let X be a n cross n real column vector. So let's first of all take this X. So it is n, it will have n rows. So we can take a1, a2, a3 till an, and it is a column vector, so it will have n row and one column, right? And with length, the trace of matrix P. So we have been asked that what will be the trace of matrix P, right? So we can calculate first this P matrix. So what it will be, so this is X, right? So we can write X as it is, so it will be A1 till AN, and this X transpose, so how we can write the X transpose is A1 till AN. Now we can do the multiplication, then this matrix, this P will be n by n matrix, right? If you do the multiplication, then here we will get A1 and dot 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 dot, here we will get A1 AN, here we will get A2 A1, and here will be A1 square. So first we will multiply this, so we will get A1 square, then here we will get A1 A2 so on, right? And now we have the second, then here we will multiply, then it will be A2 A1. Now here we will have A2 square A2 AN, right? So you got the idea, right? What we are going to get. So in the diagonal position we will have a k square, and at the end we will have a n square, right? So we will have to calculate the trace of this matrix, right? This matrix P. So what we are going to do, we are going to add up all these diagonal elements. So if you add up all these diagonal elements, what we are going to get is the a1 square plus a2 square plus a3 square plus dot 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 an square. So this is the trace of P, right? And we have given this L, right? So if you calculate this X transpose X, so this is X, so what we are going to get, L is equal to root over of a1 square plus a2 square plus a3 square dot 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 an. You can calculate this. So from here what we can write, this is nothing but L square, right? So trace of P is L square. So the correct answer for this option A. Okay, this question number 38. Now let's move to another question, that is question number 43. So this question, so this is question directly from, you can say this is standard problem. So we have given this differential equation, and what we have to ask is to write the solution of this differential equation in form of eigenvalue and eigenvector. So this is a standard problem that you will find in all of the textbook. So how you can write the solution in terms of eigenvalue and eigenvector of a differential equation. So let me just give you a hint, and so we have given this x dot t is equal to axt, right? So this is nothing but dxt upon dt, right? And axt. So what would be the solution? So solution for this would be xt is equal, so xt will be e to the power a t. This is what we can write, right? Because if you take the derivative of this, let's take derivative of this, so it will be a e to the power a t, and this is nothing but again xt, right? So a xt. So and this is nothing but we can write as x dot t, right? So we have this xt as a e to the power t. So what we have to find is simply we have to write the solution in terms of eigenvalue and eigenvector. So if you look at the so this is the standard problem, and the solution for this is this differential equation is alpha. So that we have given that constant is alpha 1 and alpha 2, and we have given that eigenvalue, that is lambda 1 lambda 2, and corresponding eigenvector is v1 v2. So in terms of if we have to write in terms of eigenvalue and eigenvector, then solution for this differential equation will be alpha 1 times e to the power lambda 1 t, uh, this will be v1 plus alpha 2 e to the power lambda 2 t v2, right? So this is the solution of this differential equation, and for detailed solution you can look at any standard book, you will find. So so this is the correct answer. Yeah. If you expand this summation, then what you will get is same as here, right? So the correct option for this 43 is A. Okay, that was all the question from 2023 paper ECE, Electronics and Communication. Next we will be solving 2022 from this branch only. Okay, that is all from my side.